Lesson 3, Analysis Methods. Section 3.1. Node Voltage Method. Experiment 3.1.1. Construct this circuit. Set V1 equals 4 volts, and V2 equals 2 volts. Measure V1, V2, and V3. Circuit construction. This is the pinout of the ADALM2000. This instrument has two pins, W1 and W2, which can output DC voltages. Connect the W1 pin to the left-hand side lead of R1, and the G pin to the bottom lead of R2. Then, connect the W2 pin to the right-hand side lead of R3. Results of experiment 3.1.1. These were the readings on the voltmeter. The question here is that, how do we calculate V3, if V1 and V2 are given? Let's apply the node voltage method to this circuit. The procedure for this method is as follows. Select one of the nodes as the reference node. Node D is better in this circuit, because this node is connected to the negative sides of the batteries, and it is usually set at ground potential. Assign a voltage to node B with respect to the reference node. In this case, V3 is assigned. Express the voltage V3 as a function of R1, 2, 3, V1, and V2, by applying Kirchhoff's current law, KCL for short, to node B. Let me show you how to obtain the expression for V3. The currents I1, 2, and 3, are defined as shown in this figure. I1 and I2 are entering node B, and I3 is leaving node B. According to Ohm's law, the currents I1, 2, and 3, are given by these equations with the node voltages V1, 2, and 3. And, KCL tells us that I1 plus I2 equals I3. By substituting I1, 2, and 3 with the top three equations, the relationship between R1, 2, and 3, and V1, 2, and 3 is obtained. It is rearranged to express V3 as a function of R1, 2, 3, V1, and V2. Experiment 3.1.2, Application of the node voltage method to the results of previous experiment. These were the readings for V1 and V2 on the voltmeter in the previous experiment. The equation derived by the node voltage method gives the voltage V3 in terms of V1 and V2. And the value of V3 was calculated as 2.32 volts. The measured value of V3 in the previous experiment was 2.32 volts, which coincided with the calculated value. Experiment 3.1.3. Construct this circuit. Set V equals 4 volts. Measure V and VB. The results of experiment 3.1.3. The measured values of V and VB were 3.88 volts and 1.94 volts respectively. Exercise 3.1. Write the voltage VB between node B and C as a function of R1, 2, 3, and V. Then, calculate VB using the measured V from the previous experiment. The answers to exercise 3.1. I1, 2, 3, are defined as in this circuit. By Ohm's law, I1, 2, 3 are given by these equations. KCL states that I1 equals I2 plus I3. By substituting the top three equations into this equation, the relationship between the voltages V and VB and the resistances R1, 2, and 3 is obtained. It is rearranged to give VB in terms of V, R1, 2, and 3. This is the measured value of V in experiment 3.1.2. Then VB is calculated as 1.94 volts. This was the measured value of VB in experiment 3.1.2. The author of this material is Takeshi Furuhashi, Professor Emeritus, Nagoya University. If you have any questions, send emails to this address.